Hello. So today I will teach you DSU, Disjoint Set Union. So what is Disjoint Set Union used for? It is generally used in dynamic graphs, that is graphs that keeps on changing. Let's say we have a graph with these 5 edges. Okay. And we construct it with the first 3. So we will join 1 and 2, we will join 2 and 5, and we will join 3 and 6. And then I ask you the question whether 2 and 6 are connected or not. So like a simple way of this to solve is DFS and BFS. That is, we can do DFS from either 2 and 6, 2 or either 6, or we can do BFS from 2 or 6, and we can see whether the either of them gets visited or not. But this approach takes O of n plus e. That is O of vertices plus edges. But DSU says that it can do this in constant time. O of constant time. So we will now see how DSU will do this. So now DSU has mainly two methods. One is find parent, which returns the parent of the given node, and secondly is union. Now union is done by two methods, either by size or by rank. Here we will follow the by size method. So what union do is it joins the parent of the smaller size node to the parent of larger size node. Okay, so now we have here 5 nodes. Initially the size of each node will be 1 and the parent of each node will be the node itself. Okay, so what does size array store? Size array stores the number of nodes in the component to which the node belongs, or to which the node is the root node. And parent stores the parent of the given node. So here we have 4 edges, 1, 2, 2, 4, 3, 5, and 2, 3. So let's join them. So let's start. So 1, 2 is the first edge. So we can join either 2 to 1 or 1 to 2, since both of them has size 1. So now let's join 2 to 1. So now this will update parent of 2 as 1, and it will update size of 1 as 2. Okay, second is 2 to 4. So now since 4 is smaller and 1, 2 is bigger, so we will join 4 to 1. That is parent of 4 to the parent of the component 1, 2. So now this will update the parent of 4 as 1 and the size of 1 as 3. Now it is 3, 5, since 3 and 5 both have size 1, so we can join any one of them. So we will join 5 to 3. It will update the parent of 5 as 3 and will update the size of 3 by 2. Okay, so now it is 2, 3. So now the component in which 2 lies has a size of 3, and the component in which 3 lies has a size of 2. So we will join 3, the parent of 3, 5, to the parent of 1, 2, 4. So now this will update the size of by 5. This will update the parent of 3 as 1. So this is how union works. So now let's say if I ask you that after joining 1, 1, 2 and third edge, let's say we don't join the last one. Okay, is 1 and does 1 and 5 belong to the same component? So we can find this by find parent. If their parents are equal, that means they are in the same component. So now let's see. So now let's see how find parent works. So we have this component here, and we want to find the uh, find parent of this node. So what does find parent finds? Find parent finds the root node of the component in which the nodes belong. So how will it do it? So it will go to this node and then it will go to the parent of this node. Then for this node, it will go to the parent of this node. And then for the root node, it will go to the parent of the root node, which is the root node itself. So now when the child is equals to the parent, then the find parent stops and it will return the root node to this, and then this will return the root node to this node, and we finally get the root node of the component in which the node belongs. So this works in log of n, that is the height of the tree. But I told you that DSU works in O of constant. So how will it work in O of constant? For this, we will use path compression. So let's see how path compression works. Now let's see how path compression works. Let's see if we have this component of 5 nodes. So finding the parent of this will take O of 5 operations. So let's reduce that. So now when we will apply the find parent operation on this, so it will go to this parent, this node, it will go to the parent of itself, then this will go to its parent, then this will go to its parent. Okay, so now when it will return, it will connect to the parent of this. So it will connect to this will connect to the parent of this, so this will connect to this will connect to the parent of this, and like this we have, so like this we have connected every node to the parent node. So now if we want to find the parent of any of those nodes, we can get this in O of 1. So that is O of constant time. So now the find parent and the union plus the path compression, the entire DSU, this entire thing works in O of constant. To be precise, this works in O of 4 into alpha, where alpha is amortized constant. So now whether we have to find whether this node or this node belongs to the same component, we can find this in O of constant. Thank you.